Hi students, welcome back to the physics class. In the previous classes, we already started our third chapter and we learned the Newton's first law of motion including momentum. The first law of motion defines force and inertia. Okay, and today we are going to learn the Newton's second law of motion and it shows how can we measure force. So, let's try to understand how Newton's second law of motion helps to measure force. Newton's second law of motion. This law states that the rate of change of momentum of a body, that is mv minus mu by t, is directly proportional to the unbalanced external force acting on it, that is the force capital F. So, F is directly proportional to mv minus mu by t, and here m is common. So, we can write it as F is directly proportional to m into v minus u by t. And we already know v minus u by t equals a, that is acceleration. Therefore, F is directly proportional to ma, mass into acceleration. And using a constant k, the above relation can be written as F equals k into ma. If k equals 1, then the equation changes to F equals 1 into ma. Therefore, F equals ma. So, once more, here F is directly proportional to mv minus mu by t. That is, the rate of change of momentum is directly proportional to the unbalanced external force. Here, v minus u by t equals acceleration. Then the equation changes to F is directly proportional to ma. By using a constant k, the proportionality sign changes to equal. And it can be written as F equals k into ma. If k equals 1, then F equals 1 into ma. That is F equals ma. So, this is the equation to calculate force. F equals m into a. That is mass into acceleration. And we already know the unit of force is Newton. And what is 1 Newton? 1 Newton is the force required to produce an acceleration of 1 meter per second square on a body of mass 1 kilogram. As we know, F equals k into ma. Then substitute the value of force, mass and acceleration as 1 in this equation. Then the equation changes to k equals 1. Next one is a problem. The velocity of an object of mass 5 kg increases from 3 meter per second to 7 meter per second on applying a force continuously for 2 seconds. Find out the force applied. If the duration for which force acts is extended to 5 seconds, what will be the velocity of the object then? Okay. So, from the question, we have the data. According to second law of motion, we know F equals ma, and here acceleration is not given. So, instead of a, we can write it as v minus u by t, that is F equals m into v minus u by t. Substituting the values from the data, we will get F equals 10 Newton. Next, we are going to find out the velocity of the object when the time extends to 5 seconds. So, for that, first we have to find out the acceleration from the same equation F equals ma. Then the equation changes to a equals F by m, that is 10 by 5 equals 2 meter per second square. Substitute the values in the equation v equals u plus 80. We will get the answer 13 meter per second. Here time is taken as 5 seconds. So, this is the velocity here. Next one is the impulse or impulse of force. So, what is impulse? In case of a ball hit by a bat or driving a nail into a wooden block with a hammer, the force acts for a short time interval. The force acts for a short time interval in this instance. This force varies with time. hence cannot be measured easily. In such cases, we measure the total effect of the force called as impulsive force. So what is impulsive force? Impulsive force is a very large force acting for a very short time. Impulsive force is the product of the force and the time. So impulse equals force into time, that is equal to F into T. This is the equation for finding impulse. Impulse is a vector quantity. Its direction is same as that of the force. The SI unit of impulse is same as that of the momentum, that is kilogram meter per second or Newton second. We usually use Newton second. Next one, impulse momentum principle. The mathematical representation of the relation between mass, velocity and time based on the second law of motion when a force is applied will be F equals m into v minus u by t, and we know impulse equals F into t. If we substitute the above equation in this, the equation changes to impulse equals m into v minus u by t into t. As t is common in numerator and denominator, t cancels each other. Then the equation changes to m into v minus u, and it can be written as mv minus mu. That is, impulse equals mv minus mu, and mv minus mu is the change in momentum. This is known as impulse momentum principle. It states that a change in momentum of an object is equal to the impulse experienced by it. Okay? The next one, how will be the ratio between the force and the time when same change in momentum occurs? Okay. So we know impulse equals change in momentum and force into time equals change in momentum. And we know F into T equals a constant. Then we can write it as F is directly proportional to 1 by T. That is, when the change of momentum is a constant, the force acting on a body will be inversely proportional to the time taken. Okay? So, that's about today. I hope you all understood the topic. You should do the textual problems on your notebook. If you have any doubts related with this, you can ask me through the WhatsApp. See you in the next class. Thank you.